You don't need a graphic calculator, just need a calculator, so just any calculator will do.
Oh, I can do that.
Graphing calculators don't help you add and subtract any more than a regular calculator. So we've got 15x over 8y squared plus 15y over 12x. What do you need in order to add and subtract rational expressions? Common denominator. Do you need that for multiplying fractions? Do you need it for dividing? No, you need it for adding and subtracting. So, I need a common denominator. Look at your denominators. Do they have addition or subtraction in them? No, if they do not, they're monomials. And the easiest way to look at it, to find that least common denominator, that least common multiple of the denominators, is just look at them and say, okay, what's the biggest thing I could divide out of both of them? Divide them both by a 4. This one specifically is 4 times what? 2y squared. This one is 4 times what? 3x. How do I get my least common denominator? What do I pull out of that 4? 2y squared, 4, and 3x? One thing they have in common. And when I say one thing, I mean all of the one thing. I just don't need the double. 4. And it's times. What about the things they don't have in common? Do I take some of it? Do I take all of it? Do I take none of it? All of it. I need all of the 2y squared and all of the 3x, and all of it is getting multiplied together. When it's monomials, do I want to multiply it together, or do I want to leave it as these 3 things? When it's monomials, multiply it together. What is 4 times 2 times 3? 24. What about variables? xy squared. Now we figured out what the least common denominator is. How do we get it? Multiply the top and the bottom of the fractions by the piece they're missing. This one's got the 4 and the 3x. What part of this is it missing? The 2y squared. This one's got the 4 and the 2y squared. What part is it missing? That's what you multiply on both top and bottom. We did a little bit of this yesterday. What is 3x times 15x? (45x squared) over 3x times 8y squared should be 24xy squared, is it? What is 5y times 2y squared? 10y to the 3rd power. Is 12x times 2y squared 24xy squared like it's supposed to be? Yes. Sweet. Once we have the common denominator, what do? Add straight across the top and the bottom? Just the top. Once I've added across the top, I combine like terms. What do we get when I combine like terms? (45x² plus 10y cubed). They are not like terms. Then what? I try to simplify. In order to simplify, when you see pluses or minuses, what do you need to do? Say it louder.
Factor.
Factor. When there's pluses or minuses, if you want to simplify, it has to be factored. What can I factor out of 45x² plus 10y cubed? 5. Leaves me with 9x² plus 2y cubed over 24xy². Can I factor it further? No, with cubes and squareds and they're not the same variable, it's not going to factor any further. Can I simplify? The 24xy² only has the opportunity to simplify with what? The 5. Does something divide out of both of those? No. It does not simplify further. Sometimes you add the fractions and they just won't simplify. And that's okay. Before I'm done though, what's the other thing I need to find when I'm working with rationals? Excluded values. To find excluded values, I set denominators equal to 0. When I'm adding or subtracting, I have the advantage of what denominator can I set equal to 0? Do I have to go back to the originals or can I go to the LCD? LCD, as long as you do it before it got simplified. Now this one didn't get simplified, but did you notice there's no addition or subtraction in that least common denominator? When there is no addition or subtraction in your least common denominator, the number is always going to be the same for the variables. 0. Because while I can split, it's always just going to be a bunch of zeros. X is not allowed to be 0, Y is not allowed to be 0. It's only when there's addition or subtraction in that LCD or in the denominators that you set equal to 0 that you're going to have anything other than 0. We did one similar to that yesterday. I'm going to give you another one similar to that, and I'm going to have you try it out on your own before we move into ones that look a little more dissimilar. Okay, seen a lot of people get stuck already on the first piece because they're looking at those denominators and they're saying, I can't divide anything out of both of them. Can you divide anything out of both 3x and 5y squared? No. Which just means, if I put this on, I moved it because I already wrote the answer, but I realized I shouldn't have yet. What was it? 3x plus
10x squared 5y squared.
Thank you. If you can't divide anything out of both of them, then when you do your LCD, you just need both of them. Everything is not in common. Least common denominator is 15xy squared. Then you multiply by what's missing. You can look at this and say, okay, the first one's got the 3x, so what's it missing? The 5y squared. I should not be talking over people. This one's got the 5y squared. What's it missing?
3x.
The 3x. So that's what multiplies on top and bottom. you get 5xy cubed over 15xy squared plus 30x squared over 15xy squared. Add fractions. 5xy cubed plus 30x squared over 15xy squared. Can you combine like terms? No, because there aren't any like terms. So you factor. Out of the top, what can I factor out? 5x. Leaving me with y cubed plus 6x over 15xy squared. It doesn't have any pluses or minuses, so I don't factor it.
Why did you take out the x?
Because there's an x on both.
Oh.
If there's x's on both, I can factor it out of both.
Yep.
I'm not going to be able to factor it any further. What can I simplify? The monomials. The x's go, and the 5 and the 15 becomes a 3 on the bottom. Y cubed plus 6x all over 3y squared. Many of you got that. Many people got stuck before getting that. To find my excluded values, I set that equal to 0, and you should end up with x is not allowed to be equal to 0 and y is not allowed to be equal to 0.
I got that.
The monomial denominators tend to mess with people more than the binomial denominators, which is where we're trying to move towards. I want a color that shows up better. Do you notice pluses or minuses in the denominator? Mm-hmm. Now we're going to start factoring. Can I factor 2x4? Greatest common factor is 2. Leaves me with an x plus 2. And I'm just going to lightly cross that out because I'm going to be lazy and say, hey, that's my fraction, which I know many of you would like to do as well. Can I factor x squared plus 2x? Pull out an x. Leaves me with x plus 2. Can I factor it further? No. What do they have in common? An x plus 2. If they have something in common, I don't need to double it. I need an x plus 2 in my denominator. I also need a 2 and an x. This is what they had in common. These are the things they don't. When you're working with your LCD, binomials are going to stay in their binomial format. The monomials will multiply, and you put them in front. 2 times x is 2x, and x plus 2. That's my LCD. I multiply the fractions by what they're missing. Look at that factored form and say, okay, this one's got an x and an x plus 2. There's the x plus 2, there's the x. The piece that was missing was the 2. This one had the 2 in the x plus 2. It's missing the x. I look at the broken down format of the LCD to see what it's missing. And we get x times negative 5x is negative 5x squared over 2x, x plus 2, because that's our LCD, minus 5x is getting multiplied by 2. I get 10x over, our LCD was 2x and x plus 2. I subtract across the top. Negative 5x squared minus 10x. People trying to combine like terms while doing this is where the biggest mistakes happen. So I highly recommend you just write numerator of first minus numerator of second. Distribute a negative if need to. Why didn't I distribute a negative? Because there was nothing really to distribute it to. You only really have to do that when it's a plus or minus. If it's easier for you to think of doing this, that's where I got negative 10x and you could do that. Over least common denominator. I must simplify. Combine like terms. Are they like terms? So I don't combine. Factor. Greatest common factor? Negative, because I don't want to leave the negative on the first thing. 5 from both and x from both. Negative 5x. Factor a negative 5x out of this. What am I left with? X plus 2. The reason we left the denominator where the binomial was not multiplied through is because now it's already factored. You don't have to try to factor it again. What simplifies out of top and bottom? X plus 2. Anything else? The x. Anything else? No. This is a very ugly way of writing negative 5 halves. Don't forget excluded values. Set your LCD equal to 0. How do I solve 2x times x plus 2 equals 0? Split it. Split it where things are getting multiplied. 2x, or I could split into the 2 and the x separately. Either way, the 2 is not going to give me anything. The x is going to tell me it's not allowed to be equal to 0. And the x plus 2 equals 0 tells me x is not allowed to be equal to negative 2. Be careful. Got to subtract it. Where are we at for time? Yep. Okay, that's what I was thinking. I got one more example for you. First thing you should start looking at is what operations between the parentheses or between the rationals, because of the fact that that is going to eventually get mixed together. Subtraction. What do you need to subtract fractions? Common denominator. Rationals are just complex fractions. Well, not complex, that's actually something different, but ugly fractions, if you prefer. What do I need in order to find the LCD when the fractions look like that? Pluses or minuses in the denominator, they need to be factored. I don't care about the numerator at this point. When I'm trying to find a common denominator, the numerator is just what it is. I leave it alone. But the denominator's got pluses or minuses I need to factor. Can I factor x minus 3? If I can't factor it, what do I do with it when it's got pluses or minuses? Put it in parentheses. What about the x plus 6? Can't factor it, so I'm going to put it in parentheses. What do they have in common? When you're looking for what they have in common, it needs to be, for monomials, you can look at what divides out of them. But do I have monomials? Technically, one's in front, but are they helpful? No. When it comes to binomials, it's the entire binomial that has to be the same. Are they? No, which means they have nothing in common. Which means my LCD needs everything they don't have in common. They do not have in common an x minus 3, and they also do not have in common an x plus 6. Do I want to multiply them out, or do I leave them in their parentheses? Leave them in their parentheses. Leave it factored for the LCD. Monomials multiply. Binomials do not. Same with trinomials. You don't want to multiply them either, but we're not really going to get trinomials there very often, if ever. What needs multiplied by the second fraction? What's it missing? X minus 3 in parentheses. What's missing on the first one? X plus 6 in parentheses. Do the parentheses actually make a difference here? When you're multiplying? Multiplying by something in parentheses versus without parentheses makes a difference because you need to distribute. If this had a plus or a minus, I would need to put in parentheses and distribute it as well. It doesn't, so I don't have to. 9 times x? 9x. 9 times 6? 54. Denominator, leave factored. 2x times x? 2x squared. 2x times negative 3? Negative 6x. Over x plus 6, x minus 3. One of the most common things I see people do at this point is now they start factoring the numerator and start crossing things off. If you do that, you're just getting a non-common denominator again. You got the common denominator for a reason. You needed a common denominator in order to subtract, so subtract now. 9x plus 54, subtracting 2x squared, subtracting a negative, turns into adding. Now what? Combine like terms. Put in standard form as you do it. So negative 2x squared, I'm putting first, plus 15x, plus 54, over x plus 6, x minus 3. And now we factor, because now we're trying to simplify. Now we're trying to cross things off top and bottom. What's the greatest common factor? One, or technically negative 1, because I don't really want to leave the negative. Can prevent me from crossing things off sometimes. Make sure when you factor out the negative, you're changing everything's signs. Can I factor further? I at least got to try full AC method. 2 times negative 54 is negative 108. Two things that multiply to a negative 108 but add to negative 15. 1 times 108. 2 times 54. 3 times brain. 36. 4 times 27. 5 times nothing. 6 times 18. 7 times nothing, 8 times nothing, 9 times 12, 10 times nothing, 11 times nothing, and I've looped back around to 12. Making any of those negative gonna get you to negative 15? I would make the big one negative. None of them are gonna get me 15. What's that mean? It's fully factored. Can I simplify it? No, because the top's fully factored, the bottom's fully factored. Does anything actually come out of both of them? No. That's it. We tried, it didn't work. What's the only other thing I need to do before I'm done? Excluded values. Set your least common denominator equal to 0. Way I'm going to make that work is split. X minus 3 equals 0. Add 3. X is not allowed to be 3. X plus 6 equals 0. Subtract 6. X is not allowed to be equal to negative 6. Sometimes they just ain't pretty. We're back on page 382. This time it's really broken up. 15 through 24, and then there's lots of little ones. 52, 58, 59, 67, 68. And by lots of little ones, it's actually not that many problems, it's just spread out. It's no more problems.